I'm tackling a problem where my GradientBoostingClassifier model, which I'm using to predict customer churn, is overfitting. That means it's learning the training data too well, including its quirks and noise, and won't generalize well to new, unseen data. I need to find ways to make it less sensitive to these noisy details. This is the core question. Which settings in my GradientBoostingClassifier can I tweak to stop it from memorizing the training data and improve its performance on new data? I think decreasing maxfeatures will help. Maxfeatures controls how many features the model considers when making decisions. If I reduce this number, the decision trees will become simpler, less prone to overfitting. The model won't get distracted by noisy or irrelevant features. It'll focus on the essential factors. Increasing maxdepth would be a bad idea. Maxdepth determines how deep each tree can grow. Deeper trees can capture complex relationships, but they're also more likely to overfit to the training data, which is exactly what I'm trying to avoid. It's like giving a child too much information at once. They might get confused and not learn properly. A higher learning would also make things worse. It makes each tree's contribution to the final model more significant. It's like taking large steps while learning. You could overshoot the target and miss important nuances. Increasing NESTIMATORS, the number of trees, usually improves accuracy, but it can increase overfitting if the trees are already complex. High maxdepth. It's not a guaranteed fix for my overfitting problem. I see you're dealing with overfitting in your gradient boosting classifier model. That means your model is learning the training data too well, including the noise, and won't generalize well to new, unseen data. We need to find hyperparameter adjustments that will create a simpler model. This will help avoid overfitting. Think of it like this. A model that's too complex is like a student who memorizes the entire textbook word for word instead of understanding the core concepts. They'll do great on the memorized sections of the test but will fail miserably on the parts requiring true understanding. I recommend decreasing the max features hyperparameter. This tells the model to consider fewer features when making decisions at each split in the decision trees. By simplifying the decision-making process, you're making the model less likely to focus on irrelevant details and noise within the data, thus reducing overfitting. It's like giving the student only the most relevant chapters to study, preventing them from getting distracted by unimportant details. Increasing the learning rate sounds tempting because you might think a faster learning process will lead to a better model. However, it is exactly the opposite. A higher learning rate means that each tree in your ensemble will heavily influence the final model. This can make your model too sensitive to noise in your training data, leading to overfitting, almost like the student focusing on only one chapter in great detail and ignoring all others. Increasing n_estimators the number of trees in your model might seem like a good idea because more trees generally improve model accuracy. However, this isn't a guaranteed solution for overfitting. If the individual trees themselves are already complex, e.g., high max_depth, adding more will only compound the problem and make your model even more prone to overfitting. It's like the student studying more chapters, but without understanding. The number of chapters doesn't ensure understanding. Increasing the max_depth parameter allows for deeper, more complex trees. This increases the model's capacity to learn intricate relationships within your data, but it also increases the risk of memorizing the training data completely, leading to increased overfitting. This is like allowing the student to cram the entire textbook but not learn the core concepts. They might ace the test by memorization, but won't understand the topic, failing to generalize in a different situation. I'm tackling a problem about hyperparameter tuning in Sklearn's gradient boosting classifier. This is a machine learning model that uses multiple decision trees to make predictions. We need to fine-tune its settings to get the best results. The model is currently overfitting. That means it's performing exceptionally well on the training data it's learned from but poorly on new, unseen data. It's essentially memorizing the training data instead of learning generalizable patterns. I'm trying to identify which settings, hyperparameters, within the gradient boosting classifier I can change to address this overfitting problem. I need to select the adjustments that will improve the model's ability to generalize to new data. Increasing the number of trees, n_estimators, might improve accuracy, but it can also worsen overfitting if the trees are too complex. It's not a surefire way to solve the problem. Increasing the maximum depth of each tree, max_depth, makes the trees more complex. This will almost certainly make the overfitting worse. I want simpler trees. A higher learning rate gives each tree more influence. This can lead to faster learning, but it also increases sensitivity to noise and increases overfitting. I need to make the model less sensitive. Reducing the number of features used in each split, max_features, simplifies the decision-making process in each tree. This is a good strategy to reduce overfitting because it prevents the model from focusing on less important or noisy aspects of the data. This is my best solution. I'm tuning the hyperparameters of a gradient boosting classifier, a powerful machine learning model that uses multiple decision trees for classification. Think of it like building a team of expert decision makers, each contributing their opinion to the final decision. We'll be adjusting the settings of this model, which dictates how well it performs. I've noticed that my model is overfitting. That means it's learning the training data too well, even the noise, and performs poorly on new, unseen data. It's like a student memorizing the textbook perfectly but failing the exam because they can't apply the knowledge to new problems. We need to fix this to build a more robust model. I need to figure out which settings to tweak in my gradient boosting classifier to reduce overfitting. I'll be analyzing the impact of different hyperparameters on the model's complexity, which is directly related to its tendency to overfit. Increasing NESTIMATORS, number of trees, generally improves performance, but it can also worsen overfitting if not careful. It's like adding more experts to my team, which is usually helpful but can lead to too much noise if they're not all independent and well-trained. I'll need to use this cautiously. Increasing MAXDEPTH, tree depth, makes each tree more complex, and that almost guarantees more overfitting. Imagine each expert in my team becoming overly specialized, missing the bigger picture. This isn't going to solve overfitting, rather it will exacerbate the issue. A higher LEARNINGRATE gives each tree more influence. This might speed up the process, but it also makes the model jump to conclusions based on the training data, increasing the risk of overfitting. It is like giving each expert on my team too much individual power. They might ignore other perspectives, leading to inaccurate predictions. Reducing MAXFEATURES, features considered per split, simplifies the decision process. It's like focusing my team on the most relevant information, preventing them from being distracted by noise. This is a good strategy to reduce overfitting. I'm looking at ways to prevent my gradient boosting model from overfitting. I need to find hyperparameters that simplify the model, making it less likely to memorize the training data's noise and perform better on new, unseen data. This is crucial for better generalization. This refers to the process of finding the optimal settings for the gradient boosting classifier's hyperparameters, those parameters that control the model's learning process. Getting these just right is key to preventing overfitting and boosting accuracy. We adjust these settings, hyperparameters, to make the model better and avoid the model from learning the training data too well, overfitting. Once you've tuned the hyperparameters, model selection is the process of deciding which model performs best. I'll evaluate different gradient boosting models with various hyperparameter settings. Then, I'll choose the one that generalizes best to unseen data based on metrics like accuracy, precision, recall, or F1 score. After I analyze the results of my hyperparameter tuning and model selection, I need to make a final decision. This involves carefully considering the trade-off between model complexity and performance. I want a model that is accurate but not so complex that it overfits. The problem is that my gradient boosting classifier model is overfitting. That means it's performing exceptionally well on the training data but poorly on new data. I need to fix this to ensure the model is reliable in real-world scenarios. Increasing the number of trees, n_estimators, might improve accuracy but could also worsen overfitting if the individual trees are too complex. It's a double-edged sword. I need to be cautious. Increasing the maximum depth, max_depth, of each tree increases model complexity, which usually leads to worse overfitting. Deeper trees can capture finer details, but this often means fitting the noise in the training data. I need to avoid this. A higher learning rate allows each tree to make a bigger impact. While it may seem helpful, this makes the model more sensitive to noise and more likely to overfit. I should use a smaller learning rate for better control and regularization. This can make the model less prone to overfitting. By reducing the number of features considered for each split, I simplify the decision trees, preventing them from focusing on irrelevant or noisy details. This directly combats overfitting. This is exactly what I need. I see this option, and I'll tell you why it's wrong. Increasing maxdepth lets each decision tree grow deeper. Deeper trees are more complex, meaning they're more likely to overfit your training data. They'll learn the noise in your data instead of the important patterns. That's not what we want. We need a model that generalizes well, not one that's just good at memorizing the training set. I see this option too, and, again, it's a bad idea. A higher learning means each tree gets more weight in the model. The model might converge faster, but it becomes too sensitive to the training data's noise, making overfitting a real threat. Think of it like taking huge steps while walking a tightrope. You'll probably fall. We want smaller, more controlled steps. Now we're talking. This is the right approach. By decreasing maxfeatures, we force each tree to consider fewer features when making decisions. This simplifies the model, reducing its capacity to overfit. Think of it as simplifying the problem. You focus on the most important factors and avoid getting distracted by irrelevant details. This leads to a more generalized, robust model. Increasing NESTIMATORS, the number of trees. Sounds good, right? More trees usually mean better performance. But, there's a catch. If your trees are too complex, deep, adding more just amplifies the overfitting. It's like adding more people to a team, but if they all work inefficiently, you won't see improvement. I think decreasing max_features is a great way to fight overfitting. Imagine, your model is like a student cramming for a test. If you give it too many facts, features, it might memorize them all but not really understand the subject. By limiting the number of facts, features, it can look at once. I'm forcing it to focus on the most important things, leading to better generalization and less overfitting. Increasing the learning rate can be risky. It's like giving the student more power to change their answers on the test based on every single question. The student might get to the right answer faster, but they're also likely to get very confused and make silly mistakes due to overreacting to small variations in each question. So, it leads to overfitting. Increasing the max_depth is like allowing the student to go deeper and deeper down rabbit holes. A deeper analysis isn't always best. It can lead to a model that's too specific to the training data, causing it to perform poorly on new data. That's overfitting at its finest. Increasing n_estimators, the number of trees, could help sometimes, but it's not a guaranteed fix for overfitting. It's like adding more students to the class. While more perspectives can improve overall understanding, it won't solve the problem of a student who is already overthinking the subject. We must find a way to control their individual approach to the problem instead of merely adding more students. This question tests your understanding of how to adjust GradientBoostingClassifier hyperparameters to prevent overfitting. Overfitting means your model learns the training data too well, including its noise, and performs poorly on new, unseen data. I'll guide you through identifying the hyperparameters that help you build a more generalized model, meaning a model that works well on unseen data, not just the training data. You're trying to fix an overfitting problem in your GradientBoostingClassifier model. I'll walk you through the options, explaining how each one affects the model's complexity and how it impacts overfitting. Reducing maxfeatures is the best solution here. This hyperparameter controls how many features the model considers when making a split in a decision tree. By lowering it, I simplify the decision trees, making them less likely to focus on irrelevant details or noise in the data. This directly combats overfitting. Increasing the learning makes each tree's contribution to the model stronger. While this can speed up training, it also makes the model more sensitive to noise in the training data, worsening overfitting. It's like taking bigger steps when learning. You might miss the mark and overshoot your target. Increasing NESTIMATORS, the number of trees, often improves accuracy, but only if the individual trees aren't too complex. On its own, it might not reduce overfitting. Imagine it like adding more opinions, helpful, but potentially noisy if individual opinions aren't well reasoned. Increasing MAXDEPTH, the depth of each tree, creates more complex trees that can overfit easily. It's like building a very tall and intricate tree structure. It might capture every single detail, including noise, resulting in a model that doesn't generalize well. This definitely worsens overfitting. These are your options for adjusting the hyperparameters of your GradientBoostingClassifier model to fight overfitting. I'll help you pick the one that directly addresses the problem. Remember, you want to choose the option that will simplify your model and prevent it from memorizing the training data's noise. We have options A, B, C, and D. Now we look at each choice to find the best solution to reduce overfitting.